Hello everybody, and welcome to another edition of Learning at Home with Mrs. V. So today what we're going to do is we're going to focus on equivalent fractions. So you'll notice I have up here on my board my reminder to you of numerator is the number up above and denominator is the number down below. The numerator is the number of parts taken or used, and the denominator is the number of total parts. All right? So that's my little reminder to you. And remember that line means divided by, and we'll get into that later. Okay, so equivalent fractions are fractions that are of equal size. So today we're going to be looking at and exploring a demonstration of that with a visual. So this kind of looks like a pizza pan. I mean, that's what I think of when I look at this. But we're going to look at this as a whole, and you'll notice here it says pizza sauce. That's for another activity, but this was the best one that I had for my my demonstration for today. So we've got this equals one whole, and so we could divide this into parts in many different ways. But we're going to start off by dividing this into halves. So we're going to investigate and see. And you probably all can tell me this, but we're going to look to see how many halves does it take to fill up this pan. All right, so I've got half up there, and then I've got another half, and when I put those together, that fills up this circle. So 2 halves, and I could write this 2 halves equal 1 whole. So what I notice here is my numerator and my denominator are exactly the same. When your numerator and denominator are exactly the same, it equals 1 whole. All right? So now I'm going to grab some other pieces here, and I want to see with fourths, how many fourths would it take to fill up this half? Okay, so I'm going to grab these pieces and I'm going to put them on the pan or on this and see how many fourths does it take to fill up half. So that will give me an equivalent fraction. It will tell me how many fourths equal half. So when I put the pieces on like so, I notice that it takes 2 of my fourths to equal half of the circle. All right, so I can write this 2 fourths equal half. And I notice I can see here that this half is covered. So how many fourths will it take to cover the whole thing, to equal 1 whole? So I've already got 2 fourths on there. I want to know how many more fourths do I need to equal 1 whole. So I've got 3 fourths, and I still have some blue, and I need to cover that up to equal the whole thing. So I'm going to put this one on there, and I notice that it takes 1, 2, 3, 4 fourths, 4 fourths to equal 1 whole. Numerator and denominator are the same, and that's what equals 1. Interesting. All right, so let me get my eighths out here, and let me see how many eighths does it take to equal 1 fourth. I noticed something too, though, that I really want to point out to you. I noticed that half, that was kind of a large area. Fourths is a smaller area of the pan. So I noticed too, I can also write this down. I'm going to write this over here. 1 fourth is less than half. And I can tell that I can tear this off again. I've got removable tape. Let's see if it works okay. All right, and I can see that this right here is smaller than the one blue area. So when I make my statement here, and I say that 1/4 is smaller than or less than half, I can see that actually with my picture. Well, take a look at eighths. Well, I know that 1/8 is less than half. It's also less than 1/4. So this is even smaller. So this representation is showing me more than just equivalent fractions. Okay, so let's go ahead and let's get back to our equivalent fractions. That's just something I noticed that I wanted to point out. All right, so if I have 1/8, put that right here. Let me line that up really good there. And let me get another 1/8 and see if I can cover up all of this one green section. Let's see here, and if I line it up just right like a puzzle, I can. I covered up all of that. So I noticed that it takes 2/8 to equal 1/4. So 2/8 equal 1/4. Okay, well, let's keep going. And I know it'll take me 2 more to cover this one up, because this is also 1/4. So let's see here. Let me get this 1/8 here, and this 1/8 here, and so how many 1/8 does it take to equal 2/4? 1, 2, 3, 4. So 4/8 equals 2/4. But I can also, I look up here, and 2/4 also equals half. So that is half. So that also equals half. So 2/4 equals half. 4/8 equals 2/4. So 4/8 also equals half. I can erase that. All right, interesting. All right. So I can go ahead then and keep covering this up. And I've got, there's another 1/8. And another 1/8, and I've got another 1/4 covered up. So then that's 1, 2, 3/4. So 3/4 equals 1, 2, 3, 4, 5, 6/8. 6/8. Interesting. All right, so if I go ahead and do another set of 1/8 and cover up this last green section, there's another 1/8, and then I have this last 1/8. All right, so then I have 8/8. Look at that, 8/8 equals 1/2. All right, now I have thirds. Can I cover this up? And let's see, here's half. Remember we said 1, 2, 3, 4/8 is half. Now can I get that to be equal to half? Let's see. Nope. And this is way bigger than a 1/4. The blue area, this right here is 1/4. That's bigger than 1/4, and it's bigger than 1/8. So that's not going to be equivalent to any of the halves, the 4ths, or the 8ths. I can't put those together. So I'm going to go ahead and put my thirds on here and see how many thirds it takes to cover up the whole thing. So there's 1/3. 2/3. Okay, and here's 3/3. And it takes 3/3 to equal 1 whole. All right. Now, my last set of fractions, I have sixths. All right, let's see how many sixths it takes to cover up. So I've got the purple. So how many sixths does it take to change this red one to purple? One red piece. There. And it takes 2 of them, 2/6. So I know that, I'm going to erase this for right now. That was just something that I noticed. So I've got 2/6 equal 1/3. Let's go ahead and put some more sixths on here. There's some interesting things that I'm noticing that I want to point out to you when I'm done with this. All right, so there's another sixth and another sixth, and I have another red part covered up. So I've got 2/3, 2/3 equals 1, 2, 3, 4 sixths. 4 sixths. All right, those are equivalent fractions. And then to cover up the last red piece, so the last third here, I've got 1, 2 more pieces. And now I've covered up the whole thing again. All right, so then I have 6 sixths equal 1. Now notice here, all of these equal 1, but our numerator and denominator are the same in each one of those. So when your numerator and denominator are the same, it equals the whole thing. Like I could do 100 100ths, and that equals 1. Or I could do 1,000,000 1,000,000ths, and that also equals 1. All right, so any numerator and denominator, when they are the same, they equal 1 whole. Now, I notice all these equivalent fractions, but I noticed something interesting about them. And I'm going to switch these around. I'm going to put thirds first here because I want to show you something that I noticed. Now, when I do a count by, when I'm counting by a certain number, 2, 4, 6, 8, 10, 4, 8, 12, 16, 20, all right? That's what I'm talking about when I'm doing a count by. And that's also finding the multiples of a number. We can multiply up by that number. That's what multiple means. But I noticed something here. So 1/3, if I multiply the top, the numerator, and the bottom, the denominator, times 2, I get 1 times 2 is 2, 3 times 2 is 6. When I multiply the numerator and denominator times 2 here, 2 times 2 is 4, 3 times 2 is 6. Now, here it's a little different. If I multiply the top and the bottom times 2, I get 2 times 1 is 2, 2 times 2 is 4. Here, I multiply the top and bottom times 2. 1 times 2 is 2, 4 times 2 is 8. This is getting interesting. Okay, top and bottom times 2, 2 times 2 is 4, 4 times 2 is 8. You can do the same thing, although here, look at this. The top and bottom have to be multiplied times 4. 1 times 4 is 4. 2 times 4 is 8. Here, it is 3 times 2 is 6. 4 times 2 is 8. So when you multiply the numerator and denominator times the same number, the answer that you get is an equivalent fraction. So say I do that with, let's try 4/6. Oh, we already have that. Well, we can make one bigger, 4/6. So I multiply the top and the bottom times 2. 4 times 2 is 8. 6 times 2 is 12. So I know that 4/6 is equivalent or equal to 8/12. So if I were to draw a picture, I could draw a picture representation and prove that these two are equivalent. Okay? So this right here is just a visual representation to show equivalent fractions. All right? So let's recap what we've learned. Okay, equivalent fractions we know are fractions of equal size. We used a picture representation in order to determine the equivalent fractions. Okay? We also have to remember that the numerator is the number at the top, the denominator is the number at the bottom. The numerator represents the number of pieces taken or shown, and the denominator is the number of total pieces in the whole. Okay? All right, so we're going to keep working on equivalent fractions. We're going to do some more things with equivalent fractions in class, in person. All right? I want you to keep watching, keep thinking, always stay curious, and I'll see you next time.